So hello guys, welcome back to my channel, and in this video we are going to discuss the HCMA problems of sound waves 10th, 11th and 12th. So guys, sorry for late uploading of the video. Now without wasting our time, let's begin. Yes, today's question, let's start from 10th. Let me read the question. 2-point sources of sound are kept at a separation of 10 centimeter. They vibrate in phase to produce wavelength 5 centimeter. What would be the phase difference between two waves arriving at a point 20 centimeter from between 20 centimeter from one source? So there are two sources. Let us think let us name them as A and B. So this is A, this is B. Distance between these two is 10 centimeter and these two is 20 centimeter. We have to find the first question is on line arriving the source, means the wavelength, the path, the phase difference on line arriving the source. So first delta x, we have formula is equals to 2 pi by lambda. What we have to find? Wait a minute. Phase difference, right? Okay. By lambda into delta x. Delta x, the path difference will be, difference between them is 10 centimeter. So we get 2 pi by lambda is, what is the lambda? 5 centimeter. 5 into 10. 2 4 pi. So we know that the multiple of the coefficient of pi of can, if it is natural number, the value will be 0. So the phase difference is 0 for this. Same for B. The phase difference never changes for like other problems. Okay. Now let us see other question. Yeah. Yes. Now let us see 11th question. Let me read the question. Calculate the speed of sound in oxygen from the following data. The mass of 22.4 liter oxygen at STP. T is 273 Kelvin. P is 1 and into 10 power 5 is the mass of oxygen at 22.4 liter is 32 grams. The molar heat capacity of oxygen at a constant volume is Cv is equals to 2.5 and Cp is equals to 3.5. So we have to find the speed of sound in oxygen. Okay. We know V is proportional to root T, right? Now let us take like V1 by V2 is equals to, that I am removing the proportionality, root over T1 upon T2. Yes. Now we know the no, not this formula. Sorry, I can't. No, we have to not apply this formula. We know that V is equals to root gamma. Sorry for the it's add. Okay. Root gamma RT by M, and by substituting the value for that, gamma is equals to, we know Cp by Cv, which gives us value how much? Cp is 2.5, Cv is 3.5 R. Okay. What we get? 1.4. 1.4 into R is 8.3. T, they gave 273, and mass they gave in grams. We have to convert it in kilograms. 32 into 10 power minus 3. By evaluating this, we get our approximate value as 310 meter per second inverse. Yes. Okay. Now let us do our other question. Last question for this session. Yes. Now let us see our last question, that is 12th question. Let me read. The speed of sound as measured by a student in the laboratory on a winter day is 340 meter per second. So there is a student and he measured speed of sound in a laboratory which is in winter season. It's 320 meter per second. So let us take V1. When the room temperature is 17 degrees Celsius. So T1 is equal to 17 degrees Celsius. If we convert it in Kelvin, we get as like 290. 273 plus 17 is 290. Okay. Now let us read. What speed will be measured by the another student repeating the experiment on the day when the room temperature is 32? So T2 at 32 degrees Celsius, that is 305 Kelvin. If the student repeats, another student repeats this experiment in other room day with other temperature. So in this question we have to find V2 value. We can take V is proportional to root T, and V2 we have to find V2 by V1 is equals to root over T2 by T1, and V2 is equals to what? V1 is 320 and T2 is 305 by T1 is what? Yes, 290. By this V2's approximate value we get like 349 meter second inverse. Yes. So guys, that's it for today. Bye bye.